Today we are doing an introduction to Chapter 5, so we're calling this 5.0. Our objective is to determine whether one number is a factor of another. Alright, these kind of serve as a warm-up, so to speak. What two numbers multiplied together give you a product of 12, Natalie?
12 and 2, or not 12 and 2, 6 and 2.
Okay, so we could use 6 and 2. That's not our only option, but it's a good option. Now, divide 12 by one of those numbers. Which one do you want to divide by? 6? Sure. What is 12 divided by 6? 2. Notice we've got the same two numbers in both of those problems. When you were first learning division, you probably had to fill in problems like that. Way back in elementary school. Alright, so we've got a couple definitions. The factor of a whole number divides, that should have an S on it, or no, we can put a factors. Okay, the factors of a whole number divide that number with a remainder of 0. Okay, if it evenly divides a number, it's called a factor. A whole number is divisible by that factor if there is a remainder of 0. How many of us have heard the word factor before? Good. We should be familiar with that word. You should also be familiar with the idea of being divisible. I don't think that's a new definition for anybody. So for number 2, we need to determine whether 146 is divisible by 2, 3, 5, 6, or 10. So is the number 146 going to be divisible by 2? Yes. Oops, sorry. Gotta turn on my pen. There we go. So for 2, it would be yes, it's divisible by 2. It says if yes, by what? So meaning if we take 146 and divide it by 2, what do we get? 73. All right. What about 3? Is 146 divisible by 3? If you're not sure, you can take a calculator or off to the side do some long division. If we take 146 and try to divide it by 3, does it divide evenly? I hope our answer is no. So that means we can't fill in that last column. Okay. If we try to divide it by 3, probably multiply it by 4, get a 12. Do you remember this old school long division stuff? Okay, then 3 would go into 26. 8 times. We'd have a remainder of 2 left over down there at the very bottom. So it doesn't divide it evenly. So we don't have to fill in that column. We just put an X there. All right, what about by 5? No, hopefully you can look at that and know that that's not going to work for us. What about by 6?
No.
We got a mixed response here. So let's go the long division route. How many times would 6 go into 14? 2 times. 2 times 6 is 12. Subtract and we get 26 when we drop that 6 down. How many times does 6 go into 26? 4. 4 times 6 is 24. Do we have a remainder? We've got a remainder of 2. So is 6 going to divide evenly? No. Nope. So mark that one out. What about 10? No. Okay, again, you could use your long division if you needed to, but hopefully with 5 and 10, you can just look at it and know that it's not going to work out. Have you learned your divisibility rules before? this sort of thing look familiar? Deciding if a number is divisible by another number. This is something you should have learned before. We're just reviewing it. So here's a list of rules. A number is divisible by 2 if the ones digit is divisible by 2. So let's just off to the side here do an example. If I were to put up the number 148 and the number 148, which is the ones digit? The 8. Okay, so the number at the end of a whole number is your ones digit. Are we all familiar with the ones digit? Okay, you got to be able to identify it to use these rules. Just want to make sure we review that. All right, a number is divisible by 3 if the sum of its digits is divisible by 3. So let's pop that 148 back up there. What would the sum of its digits be? 13. So to find the sum of the digits, we take 1 plus 4 plus 8, and that would give us 13. We all okay with how to find the sum of a number's digits? If you're not, it's going to make these rules a little harder. Okay, take that away again. A number is divisible by 5 if the ones digit is a 0 or 5. I think that's one we're probably familiar with. The next one we have to edit just a little bit. A number is divisible by 6 if the number is divisible by 2 and 3. So in your notes, I think it has the word or. We need to change that to and. It's got to be divisible by both 2 and 3 for it to be divisible by 6. We all make that change? All right, and our last one, a number is divisible by 10 if the ones digit is a 0. All right, number 3 on the back of your notes page. State whether 39 is divisible by 2, 3, 5, 6, or 10. It says use your rules. Okay, so is it going to be divisible by 2? Okay, our answer is no. Can we explain why? Deja? Okay, it's an odd number. I would be okay with that. You could say it's an odd number. Or by the rules say that the ones digit has to be divisible by 2. Well, what's in the ones digit? A 9. So we could say 9 is not divisible by 2. I'm fine if you use a little division sign for a shortcut there. 9 is not divisible by 2, so it's not going to work. All right, our next number is a 3. Is 39 divisible by 3? Yes, why? Good. So you could say 3 plus 9 equals 12. 12 is divisible by 3. You don't have to put what that equals, but you can if you want to. All right, what about by 5? No, based on our rules, how do we know that it's not divisible by 5? Okay, so 9, you could just say ones digit is a 9. Ones digit is 9. That's why it's not going to be divisible by 5. I kind of wrote that a little high. You could also say 9 is not equal to 0 or 5. One's digit is a 9. What about 6? We seem less sure about this one. No, why not? Ryan? Good. So you can just say not divisible by 2. So it has to be divisible by both 2 and 3. So if it's not divisible by 2, it won't be divisible by 6. All right, what about 10? No, why not? What's not 0? Okay, 1's digit is not 0. Or you could again say 1's digit is a 9. 1's digit is not 0. Are we all okay with how we're explaining our answers over here? Okay, this is how I'm going to expect you to explain your answers on your homework, or if this comes up on a quiz or a test. We've got to be comfortable with explaining ourselves. No other questions about number 2? Sorry, number 3? Deja? If the answer is yes. Yep, we still put an explanation when we divided by 3. So we said 3 plus 9 was equal to 12, and 12 is divisible by 3. So we used our rule, gave an explanation. So for example, if you have a number that is divisible by 5, and you say yes, you could put that your 1's digit is a 5, or 1's digit is a 0. We can always explain how we got our answer. Okay, are we ready to try the next one? All right, this time we're using the number 118. 2, 3, 5, 6, and 10. All right, we're going to pull sticks on this one. Jakeem, is 118 divisible by 2? Okay, I would agree with yes. Yes, it is. Ellie, why is 118 divisible by 2? Okay, it's an even number. What number's in the 1's digit? 8. So 8 is divisible by 2. If you put it's an even number, I would probably be okay with that. But if we're using the rules talk about whether or not the 1's digit is divisible by 2. All right, let's move on to 3. Jeriel, do you think 118 is divisible by 3?
No.
Okay, I would agree with no. Deshaun, can you explain why? What's not divisible by 3? Not just the 8, but what does our rule say to do with all those digits? What little S word is in there? It tells us what to do. The sum. So sum means we're doing what operation? Anybody? Adding. So 1 plus 1 plus 1 plus 1 plus 8 is equal to 10, and is 10 divisible by 3? No, 10 is not divisible by 3. So we took the sum. The sum was not divisible by 3, so that means overall 118 is not divisible by 3. Logan, is 118 divisible by 5? No, I would agree with that response. It is not divisible by 5. Houston, can you tell me why 118 is not divisible by 5? In which spot? There's not a 0 or 5 in which place? Good. So you could say there's not a 0 or 5 in the ones digit, or you could say the ones digit is a... What's our ones digit? An 8. So you could say ones digit is not 0 or 5. You could say the ones digit is an 8. So I'll put the other way this time, 0 or 5. Ones digit is not 0 or 5. It's another way of explaining it from how we did it last time. All right, we move on to 6. Deja, is 118 divisible by 6? No, I agree with the no answer. Keon, why is 118 not divisible by 6? Very good. It's not divisible by 3. So therefore it cannot be divisible by 6. It's got to be divisible by both 2 and 3. Natalie, is 118 divisible by 10? Yeah. I agree with you there. It is not. Delaney, can you tell us why? If you need to, you can look back at the rules. What do the rules say about being divisible by 10? You're on the right track. Our rules say that the ones place would have to be what number? A 0. Is our ones place a 0? Nope. So we could say ones digit is not 0. That's how we know that it's not going to be divisible by 10. All right, they've got a bigger number for us now, 876, but we're still going to use those same rules. 2, 3, 5, 6, and 10. Jalen, is 876 divisible by 2? I agree. Yes, it is. Jaquan, how do we know that? Very good. The ones place, which is 6, is divisible by 2. Okay, if you want to put what that equals, you can. You don't have to, though. All right, next up is 3. Jamal Dixon, is 876 divisible by 3? Yeah. Jamal says yes. I agree with Jamal. Ryan, can you tell us why? 8 plus 7 plus 6 is 21. And 21 is divisible by 3. I agree. That is a perfect explanation. Jamaro, is it divisible by 5? I agree. It is not divisible by 5. Tariana, can you tell us why? The ones digit is a 6, meaning that it's not what two numbers? 0 or 5. Ones digit is not 0 or 5. If you would rather put that the ones digit is a 6, that's also fine. I know 6 is not 0 or 5. Kion, is this number divisible by 6? Do you want to rethink your answer? What do our rules say?
Yeah.
You're going to go with a yes?
Yeah.
I think that sounds better to me. Yes, it is divisible by 6. Lexi, can you tell us why?
Because it was divisible by 2 and 3.
Good. So it was divisible by 2 and divisible by 3. It was divisible by both of those, so it is divisible by 6. Is it divisible by 10, May? No, I agree with you on that. Danielle, can you tell us why? No 0 in the 1 spot. So 1's digit is not 0. Not 0. We feeling comfortable with these rules? Like we know what's going on? This is what your whole homework worksheet is like. Okay, it's got it set out for you. It gives you a number. It's got 2, 3, 5, 6, and 10 listed. And it's got 2 columns. One for a yes or no. The next column for an explanation. But before we get to that, we've got a little bit more in our notes. Nope, too far. Okay. We know that 5 and 12 are factors of 60 because 5 times 12 equals 60. So if 5 and x are our factors, 5 times x equals... Don't make it harder than it is. How would we read 5 times x? 5x. That's all they're looking for there. X goes in that blank. What is important here that I think it's not really highlighted is that x is called a factor. So even though we don't know what it is, it's a variable, it's still considered a factor. Okay, because we could divide 5x by x. All right, this slide is not terribly exciting because all of our blanks are pretty much the same. An expression like 5x is called a... Anyone remember? There's one term. Nobody remembers. Keon might remember. What? A monomial. Very good. 5x is a monomial. A monomial, for that recall, a monomial is an integer, a variable, or a product of variables. So, can we give some more examples of monomials? Keon's got one? Okay, we could do something like 3x. I'm going to shorten this up so I've got a little more space here. 3x is a good monomial. Any other monomials we can think of that maybe look a little different? Natalie?
2y.
2y, we could use a different variable. Ellie?
Negative 7z.
-7z, we could throw a negative in there. Okay, I'm going to throw another one up there that is a monomial. I'll write it above. I'm going to call it negative 327xyz. Put all of your ideas together. This is still a monomial. Even though we're using a negative, even though we've got multiple variables, it's still considered one term because all we're doing there is multiplying all of those things together. It's just one big product. Can anyone come up with some non-examples, things that are not monomials? Can?
4x plus 5.
Well, let's just leave it at 4x plus 5. Because if we put an x on that 5, what could we do? combine like terms, and then all of a sudden it's a monomial. But if we cannot combine these, then that is not a monomial. We've got two terms there. Any other non-examples? Well, we could have something like y plus 2z. We could have 3 minus x squared plus y cubed. Okay, anything that's not just a single term. Those are non-examples. Questions about what is or is not a monomial? Okay, then let's practice it a little bit. Determine whether each expression is a monomial. Now, before we make a final decision about 6a, what do you think I should do? Distribute. Let's see if distributing changes anything for us. 5 times x is 5x, plus 5 times y is 5y. Can I combine those? No, why not? Not like terms. We've got different variables there. So if this is what we're left with, is this a monomial? No. How many terms does this have? 2 terms. It's a binomial. All right, what about letter B? Okay, so after that example I put up on the last slide, hopefully we can see that yes, this is a monomial. Okay, we've just got all of these things multiplied together. That is the end of our notes for today.